Welcome back, class, to continue 4-4. Today is going to be our final notes on factoring, our third day. Today we're going to focus on just a couple special cases, and I want to make sure you are aware of that come up when we're having the conversation about factoring. So the first thing I'd like us to remember is what's known as the difference of squares. Okay? So when you have two squared terms that are being subtracted, it factors into a plus and a minus because we want that middle term to cancel out. So you get the two square roots of those things, one parenthesis being added, one parenthesis being subtracted. So for example, when we're looking right here, the x squared is a perfect square. Anything to an even power is a perfect square. So x squared breaks down into x and x. 64 is also a perfect square. It is 8 times 8. So I like to write those two things out because then I think it's really easy to see you have x plus 8, x minus 8. You take whatever you break it down as. You have this plus that, and then this minus that. So now just to recall what these perfect squares look like. We're looking for numbers such as 1, 4, 9, 16, 25, 36, 49, 64, so on and so forth. Those are the types of numbers we're looking for. So whenever you see an x squared minus a number, there's only two terms. I want you to have in the back of your mind, it could be the difference of squares. Even if the number is too big and you don't recognize that it's a perfect square, check it out. Go to your calculator, take the square root of it, see if it is. Now, for two examples of this, y squared minus 121. So I know for a fact y squared is, okay? Y squared is y and y. And again, what set me up in the first place thinking this might be difference of squares, it's only two terms, they're subtracting, and I know for a fact that y squared is a perfect square. Well, what about the 121? Well, if you check it with your calculator, the square root of 121 is 11. So once I recognize that, how the two pieces break down, what their square roots are, well, I like to just set up my structure. I know I'm going to have a plus and a minus when I'm using the difference of squares. So I have the y plus 11, and I have the y minus 11. And my problem is done already. Looking at the next one, now this time the x squared has a number with it, but that is okay because notice what that number is, a 4, and then I see a 49. Both of those are perfect squares, so the difference of squares is definitely in my mind for this one. I look, so the 4 breaks down into 2, and the x squared breaks down into x. So this time that 4x squared, if you were to square root it, we're talking about 2x. That's the piece that makes up the perfect square. And then 49, the square root of that is 7. It breaks down into 2 sevens. So again here, I definitely know I'm talking about the difference of squares here. Two perfect squares being subtracted. So to set up my structure, I have the plus and I have the minus. And now I just write in 2x plus that 7, then 2x minus 7. And my problem is finished. So that's the pattern you are always going to see with difference of squares, the plus and the minus. Now, the other special cases I want you to be aware of today is sometimes there's going to be a GCF, a greatest common factor, that you can pull out first, all right? So I want you always watching for that. If there's a GCF, pull it out first. It actually makes the factoring a whole lot easier if you do. So, for example, I have that first one, 5x squared plus 45x plus 90. Something you may notice is all of those numbers, the 5, the 45, and the 90, all of those are divisible by 5. So I'm going to pull that 5 out right away. All right, I'm going to factor out that 5 as the greatest common factor. So 5x squared, and I'm dividing that 5 out, leaves me with just x squared. 45x, I'm dividing 5 out. Well, 45 divided by 5 is 9, so that gives me 9x. 90 divided by 5 gives me 18. So again, to begin this process, completely factor out that GCF. So I'm taking that 5 right out. Now I'm ready to factor what's left. So you are still going to have that 5 out front, but now in terms of making my parentheses, all I'm concerned with is what's inside the parentheses, what's left after I've taken that 5 out. So where does that x squared come from? That x squared comes from x and x. How about that 18? Well, the 18 has some options. 1 and 18, 2 and 9, 3 and 6. And now we're trying to choose a combination that, when multiplied with those x's, will give me 9x. So I look at those, and I'm going to choose 3 and 6. Because when I check to make sure that that worked, that gives me 3x, that gives me 6x, that does give me the 9x that I was looking for. So that is going to be how this completely breaks down. But it is necessary to pull out the 5 first. If you don't have that 5 pulled out, it is not in its completely factored form. Now, in our next one, the negative x squared plus 6x minus 8. In this one, notice the x squared term is negative. Now, when the x squared term is negative, instead of pulling out a number, we're actually going to pull out that negative. It's going to be a whole lot easier factoring this thing if you pull out that negative first. So to pull out that negative, think of it like pulling out a negative 1. When you pull out a negative, all it's going to do is flip every sign inside what's left. And again, it's going to make factoring these things so much easier. So when you have this case where your squared term is negative, pull out that negative, which is going to flip the sign of everything when you write it in the parenthesis. And now what do? Well, you leave that negative there just like we left the 5 there before. And now all I'm concerned with is factoring what's inside that parenthesis. So to factor this inside the parenthesis, I focus on the x squared. So to get x squared, that is x and x. The 8, well, that can be 1 and 8 or 2 and 4. Now, the thing that I find interesting is notice it is a negative 6x. All right? So we have to multiply to negative 8, but then somehow combine the like terms to be negative 6x. So to multiply to be positive, yet add to be negative, we're talking about two negative numbers. And finally, the pair that I'm going to choose to combine to be that 6 is the 2 and the 4. And again, I'm going to check just to make sure I've done this right. So that combination gives me negative 2x. That connection gives me a negative 4x. That does indeed give me the negative 6x I was looking for. So that is the proper factored form. Moving right along to our next example. So the 24x cubed plus 20x squared plus 4x. Now, one thing I notice here. Notice how every one of those numbers is divisible by 4. So the first thing that I'm going to do, I'm going to pull that 4 out. The next thing that I notice, my x is in every term. My variable is in every term. of this. So what that's communicating to me is I can pull it out. Now again, I can only pull out an x because that last term only has an x to give. But I want you to realize if your variable is in every term, you also must pull that out. And it's something you should probably realize anyway, because you don't know how to factor cubics. So the fact that it's not a quadratic here means you should be looking for something to pull out because you don't know what to do otherwise. Now, when you pull that out, let's see what we have left. So focusing on the first term, 24 divided by 4, well, that gives me 6. X cubed, and I'm dividing one of those x's out. Well, 3 minus 1 leaves me 2 of those x's. Focusing on the second term, 20x squared divided by 4x. Well, 20 divided by 4 leaves me with 5. And then x squared, and I'm taking one of those x's away. 2 minus 1 just leaves me with x. 4x divided by 4x. Well, 4 divided by 4 leaves me with 1. And then x, and I'm pulling out the only x that was there, so the last term doesn't have an x anymore. So notice how nicely this turned out. We were left with a quadratic, which is what we needed. That's what we know how to factor. So now to completely factor this though, we still have our 4x there, but now we need to figure out how to break down what's left in the parenthesis. Now, looking at that 6x squared, how do we get 6x squared? Well, remember this one, we actually have some options for, okay? This one, that 6x squared, could come from 3x times 2x, or 6x and just x. So remember, this time we have some options. So we're going to try one option. If we try every possible combination using it and it doesn't work, then we'll transition to the other option. So I'm going to try the 2x, or the 3x and the 2x first. All right? See if we can get that to play out. Now, how about the 1? Well, 1 is easy. The only way to multiply to 1 is 1 and 1. So let's see if we can get this to turn out. So luckily for us, we know that those two numbers have to be 1s. That's the only possible combination here. So let's see if the 3x and the 2x worked. So here I'm getting 2x. There my combination gives me 3x. So does that add to the 5x that we needed? And the answer is it does. So in terms of this factoring, that is the truly factored form. That's as far as we can go. And our last example, negative x squared plus 3x plus 28. This is another one of those examples. We have a negative there, okay? Our squared term has a negative. So I'm going to pull out that negative from everything. And in doing so, it flips the sign of everything that I have left. So now I look at this. I still have my negative out front. And now I have to break down what's left in the parenthesis. All right, x squared, where does that come from? Well, that comes from x and x. How about that 28? Well, 28 can be 1 and 28, 2 and 14, 3 and 7. Now the thing I want you to note, you are multiplying to a negative 28. So again, when we recognize we're multiplying to a negative number, what that means, one number in the pair is going to end up being negative. And I'm sorry, that's not 3 and 7. That should be 4 and 7. So one number in those pairs is going to have to be negative. So I'm going to jump down to the 4 and the 7. I think most of you will be drawn to those two numbers because if I make a negative 7 and a positive 4, notice I get 4x, negative 7x, and that's going to give me the negative 3x that I was looking for. So that's going to be the end, the final factored form. All right, so thank you so much for joining me. Please make sure you have all this written down. Come back with any questions you may have, and we will do our practice work in class.